Hello students. In this video, we'll be delving into the intriguing world of metals and non-metals. As you might already know, these elements exhibit quite distinct properties, both physically and chemically, which makes them vital to understanding the composition and behavior of matter. Let's start by discussing metals. Metals are elements that are typically solid at room temperature, with mercury being the notable exception as it remains in liquid form. They are known for their shiny appearance, which is referred to as metallic luster. This lustrous quality, combined with their ability to conduct heat and electricity efficiently, makes metals indispensable in various applications, from electrical wiring to kitchen utensils. Metals are also malleable and ductile, which means they can be hammered into thin sheets and drawn into wires without breaking. For example, aluminium can be flattened into foil, and copper can be drawn into thin wires, which are then used extensively in electrical circuits. Moreover, metals like iron and titanium are renowned for their hardness and strength, making them essential materials in construction and engineering. One of the reasons metals are so versatile is their ability to lose electrons easily during chemical reactions, forming positively charged ions. This characteristic makes them electropositive and plays a crucial role in their chemical behavior, especially in reactions with non-metals. Now, let's turn our attention to non-metals. Non-metals are elements that contrast sharply with metals in their physical and chemical properties. They are generally poor conductors of heat and electricity, lack the shiny appearance of metals, and are often brittle rather than malleable or ductile. For example, sulfur and phosphorus are non-metals that crumble easily when hammered, unlike the flexible and durable nature of metals. Non-metals can exist in various states at room temperature. Some are solids, like carbon and sulfur, while others are gases, such as oxygen and nitrogen. Interestingly, bromine is a liquid non-metal, highlighting the diverse physical forms non-metals can take. Chemically, non-metals tend to gain electrons during reactions, forming negatively charged ions, which is why they are considered electronegative. This property is particularly important in the formation of compounds like salts. Moving on to the chemical properties, metals exhibit a wide range of reactivity. For instance, some metals, like sodium and potassium, react vigorously with water, while others, such as gold and platinum, are much less reactive and do not tarnish easily. This variability in reactivity is organized in what we call the reactivity series, where metals are ranked according to their tendency to react. Metals also undergo a process known as corrosion, where they react with oxygen and moisture in the air, leading to the formation of oxides. Iron, for example, reacts with oxygen to form rust, a process that weakens the metal over time. However, the tendency of metals to react with other substances can also be beneficial, such as in the formation of alloys, mixtures of metals that often have superior properties compared to pure metals. Brass, an alloy of copper and zinc, is harder and more durable than copper alone. Non-metals, on the other hand, typically form covalent compounds by sharing electrons with other atoms. They can also react with oxygen to form oxides, which are often acidic. For example, carbon reacts with oxygen to form carbon dioxide, a gas that plays a crucial role in the Earth's carbon cycle. Unlike metals, non-metals do not react with water in the same way and generally do not react with dilute acids to produce hydrogen gas. When metals and non-metals react with each other, they tend to form ionic compounds. These compounds are held together by ionic bonds, which are formed when metals lose electrons and non-metals gain those electrons. The resulting electrostatic attraction between the positively charged metal ions and the negatively charged non-metal ions creates a strong bond, leading to the formation of compounds like sodium chloride, commonly known as table salt. Ionic compounds have several distinctive properties. They usually form crystalline structures, are generally soluble in water, and have high melting and boiling points due to the strong forces holding the ions together. Additionally, while ionic compounds do not conduct electricity in their solid state, they do conduct electricity when melted or dissolved in water, as the ions are free to move and carry an electric current. A particularly interesting chemical reagent is aqua regia, a mixture of concentrated nitric acid and hydrochloric acid, known for its ability to dissolve noble metals like gold and platinum. This powerful mixture, often referred to as royal water, is used in various industrial processes, including the refining of precious metals. Now, here's a question for you to test your knowledge. What type of bond is formed when metals react with non-metals? Please share your answer in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.